Welcome to Advanced Programming. This course will deepen your programming skills by exploring two important paradigms: object-oriented programming, OOP, and functional programming. The first part of the course is dedicated to OOP. This widely used approach focuses on organizing code into objects, which combine data and the functions that operate on that data. We'll cover core OOP principles like classes, inheritance, and polymorphism, learning how to design and build robust, maintainable software. The second half of the course dives into functional programming. This paradigm emphasizes immutability in pure functions, leading to more predictable and testable code. We'll explore concepts like higher-order functions and lambda expressions. Understanding how functional programming can simplify complex tasks and improve code quality. Our very first lecture will introduce encapsulation, a fundamental OOP concept. Encapsulation is about bundling data and methods that operate on that data within a class, controlling access and preventing unintended modifications. Think of it as creating a protective capsule around your data. This promotes modularity and reduces the risk of errors. In object-oriented programming, we often create new data types called classes. Encapsulation is a technique that allows us to hide the internal details of these classes, how the data is stored and how the operations work, from other programmers who might use them. This simplification makes the code easier to use and understand, and it also helps to prevent accidental errors by controlling how the data is accessed and modified. It's a key principle for building robust and maintainable software. In object-oriented programming, encapsulation plays a crucial role in ensuring data integrity and simplifying code maintenance. By carefully controlling how data and methods are accessed, we achieve several key benefits. First, encapsulation protects data from unauthorized or accidental changes, preserving its integrity. Second, it enhances security by hiding sensitive information from unauthorized access. Third, it makes code easier to use. Programmers working with a class don't need to understand its complex internal workings. Finally, and perhaps most importantly, encapsulation makes code easier to maintain. Because the internal implementation is hidden, we can change it without affecting how the class is used elsewhere in the program. This allows for flexible updates and improvements without breaking existing code. Structs and classes share the role of defining data structures, but their default access levels differ. In many languages, members of a struct are public by default, meaning they're accessible from anywhere. This makes structs convenient for simple data containers. Classes, however, typically have private members by default. This means that data and methods within a class are only accessible from within the class itself. This default privacy is a cornerstone of encapsulation, allowing classes to control how their data is accessed and modified, promoting data integrity and code maintainability. So, public by default for structs, private by default for classes, that's the key difference to remember. In object-oriented programming, we use classes to create objects, and a crucial concept is data hiding. This means an object's internal state, its data, is kept private. Think of it like the inner workings of a machine, hidden from the user. We interact with the object through methods, like buttons and levers on the machine, that provide a controlled way to access and modify the data. These methods are often called getters for retrieving data and setters for changing it. This brings us to access control. We use access specifiers to define the visibility of class members, like attributes and methods. Private members, the default, are only accessible within the class itself. Ensuring data integrity. Protected members, which we'll explore later when we talk about inheritance, are accessible within the class and its subclasses. Finally, public members are accessible from anywhere, providing the interface through which other parts of the program can interact with the object. Data hiding and access control are essential for building robust, maintainable, and secure software. When we create objects in object-oriented programming, we often need to initialize them with specific values. That's where constructors come in. A constructor is a special function within a class, and it has some unique characteristics. It shares the same name as the class itself, and interestingly, it doesn't have a return value, not even void. The most important thing about a constructor is that it's called automatically whenever we create a new object of that class. We, as programmers, don't call it directly, the system does it for us. Now, if you don't explicitly define a constructor in your class, the system helpfully provides a default, empty constructor. But what's its access modifier? Well, that default constructor is typically public. And here's a thought-provoking question: can we create a private constructor? The answer is yes. And this technique is actually used in a design pattern called the singleton pattern, which ensures that only one instance of a class can ever be created. We'll explore this pattern in the later lectures. Why do we need getters and setters? They're all about controlled access and flexibility. We want to protect our data, that's data hiding. Getters and setters provide a way to interact with private data members, ensuring that any access or modification happens through controlled methods. How does it work? We declare data members as private, preventing direct access from outside the class. Then, we create public methods, getters to retrieve the value of a private data member, and setters to modify it. This allows us to add logic within the getter or setter, like validation or calculations, giving us flexibility and control over how our data is handled. Here is an example program written in C++. There is a car class with private data, namely balance and password, and a constructor with the same name as the class. There are also public methods, the getter getBalance and the setters deposit and withdraw to let us interact with the private data. Now, practice writing the same program in Java and Python. Now, let us practice what we have learned so far with the following exercises. First, in exercise 1, create a car class as shown in the slide. In the previous exercises, you have learned about creating classes with multiple, but separated, constructors. Now, in exercise 2, create a laptop class with multiple constructors and constructor chaining as shown in the slide. In this exercise, you will practice creating different classes and write program to let them interact with each other. Let's recap what we have learned so far. Encapsulation is a cornerstone of object-oriented programming. It's all about bundling data and the functions that operate on that data within a class. Classes and structs both do this, but a key difference lies in data security. Classes typically default to private members, offering strong encapsulation, while structs often default to public members. Finally, constructors are special mechanisms that automatically run when an object is created. They're powerful tools for initialization, but poorly designed constructors can introduce errors, so careful design is essential. Class diagrams are essential tools in object-oriented design. They provide a visual representation of the classes in your system and how they relate to each other. Think of them as blueprints for your code. A class is depicted as a rectangle, containing its name, attributes, and methods. As you can see in the example diagram, the class is named Circle. Then, in the next part, you can see the attributes, radius and color. The minus sign at the beginning indicates that these attributes are private. Then, in the last part, you can see the methods. The first two methods have the same name as the class, so they are constructors, one default and one parameterized. Then, the last two methods are getter. Note that, the plus sign at the beginning indicate that all these methods are public. Now, practice reading class diagram and all you have learned about encapsulation with this exercise.